So this is a request from a viewer. This is a level 2 NCEA mathematics applied calculus methods and solving problems 2017. For some reason they wanted to know this one. We're just going to use the formulae sheet which is given to all students, and I'm going to be using the only emulator I could find for the most common calculator that students use. So with that said, let's do it to it. So the first question says a function f is given by f of x equals x to the 5 plus 3x squared minus 7x plus 2. Find the gradient of the graph of the function where x equals 1. For all of these questions, you're going to be either differentiating or anti-differentiating, aka integration. Okay, so if you do the question and you don't do one of these two things, then you're doing something wrong. So it says that the gradient of the graph, so if we see gradient, we know we're going to use differentiation, and it's where x equals 1. So in other words, we want to find f prime and put in 1 in there and find some number. Okay, so we've got f of x, and I always copy it down. The reason I do that is because it minimizes the chance that I'll make a screw up. It's just really good if you've got the formula, to have the formula and work from the formula rather than jumping between things. So I've got that. So f prime of x is therefore going to be 5x to the power of 4. The 5 comes out the front and the indices loses 1. The 2 comes out the front, so we've got 6x and then it loses 1. We don't really need the 1. And then it's minus 7 and the plus 2 goes away. So now we can put in 1 into our little equation, which is going to make life really easy. Plus 6 to the power of 1 minus 7. So 1 to the power of 4 is 1. So this is going to be 5 plus 6 minus 7, which is going to be 4. And I always write it 4 over 1 because remember it's dy dx, it's rise over run. So when we come to graph it, it means that for every 1 it goes across, it goes up 4. Maybe that's a little bit out of scale, so maybe like this, a bit better. For every 1 that it goes across, it goes up 1. On to part B. So this is the first time I'm seeing this as well as you. So find the equation of the tangent of the graph. So when we find the tangent, we're always going to use differentiation of the graph of the function this at the point such and such. Okay, so if two curves are said to be tangent, it means that they intercept at one place only. Okay, and where they intercept, they're going to have the same gradient. So in other words, if this is a curve here and we want a tangent to that curve, it's going to just touch it there once, and where they touch, the gradient of this one is going to be the same as the gradient of that one. M, of course, is the gradient. All right, so what do we need to do? We need to find the gradient of this curve here at this point here. So you should be thinking where x equals 2, y equals 18, and that's an ordered pair. So f of x is given as 6 plus 14x minus 2x cubed. I don't know why they've got it in Taylor's series form, but we'll go with that. So f prime of x, that's the constant, and then the next most complicated, then on. So that 6 is going to go away, the 14 is going to come down. 3 times -2 is -6x, and then we lose 1. So that's the gradient function. And I'm going to put x equals 2 to find what the gradient to that point is going to be. So 14 minus 24, because 2 squared is 4. 4 times 6 is 24. Okay, so that's going to be minus 10. So the gradient is going to be minus 10 at that point to 18. So m is going to be minus 10, and the point that we've got is to 18, and that's going to be x1, that's going to be y1. So we can apply our formula, y minus y1 equals mx minus x1. They don't give this. I don't think they may do. Do they give this? No, they don't give it to you. This is a really important equation that you need to know. So m is minus 10, x1 and x and y1. So y minus 18 is going to be equal to negative 10 x minus 2. So y is going to be equal to negative 10x plus 20, because negative 10 times negative 2 is plus 20, plus 18. So collected those terms. So 10x plus 38 is our final answer. The next one looks like it's a bit of a kinematics one. The movement of an object is recorded from the time it passes a fixed spot. So it's already got a velocity at time equals 0. Some number. After t seconds, it has a speed v meters per second. So the physics students there should be having kittens right now, because we know that velocity and speed are not the same thing. They're related, but they're not the same thing, which can be modeled by the function. V as a function of t is 0.5 t squared minus 2t plus 1. Use calculus, so you're going to have to differentiate or integrate to see how long it takes to reach the acceleration of 2.8. So they want to know how long it takes, so you're going to have t equals some number as your answer, and they want the acceleration as a function of time to equal 2.8 meters per. Okay, the velocity as a function of time is the derivative, acceleration, as this is an A, not a 9, is the derivative with respect to time of the velocity with respect to time. So we're going to have to differentiate that and set that answer to that, and then solve for t. Okay, so v of t is 0.5 t squared. Okay, so when we differentiate that, it's going to do something really nice. So the acceleration as a function of time is going to be 2 times half, which is 1 t, and then it loses 1 into c, and then the minus 2t just becomes 2. So the acceleration at any time is going to be equal to t minus 2. So t minus 2, we're going to set to add 2 to both sides. So t is going to be equal to 4.8 seconds. Moving right along to D, a tangent to the graph of the function f of x equals 3x squared minus 4x has a gradient of 2. Okay, so it's differentiated already, and passes through a point 5a. So the tangent passes through this point, not necessarily this graph here. So the tangent is going to be a straight line in that form. Where a is a constant, find the value of a. Okay, so where they are tangent, they have the same gradient. So in other words, this one up here is going to be a parabola, and we're going to need to find the, if you imagine that's crossing in there, just touching it there, it's going to have the gradient of 2, and then we're going to find whatever x equals 5, and then we're going to find a. Okay, I'm just thinking aloud. All right, so if f of x is 3x squared minus 4x, then f prime of x is 3 times 2 is 6, x to the power of 1 minus 4, so 6x minus 4, and we set that equal to 2 and then solve for x. So 6x is going to be equal to 6. It's pretty easy to find out. Divide both sides by 6, so x is going to be equal to 1. All right, so if x equals 1, let's go to the original equation and find where it crosses where exactly they cross. So f of 1, I can think of another way actually of doing this, but let's stick with this way, is 3 to the power of 1 squared minus 4 times 1. So 3 minus 4 is minus 1. So maybe we can, there's one way of practicing this, but we'll stick to this one. So we know that this gradient passes through the point 1, negative 1, and has a gradient of 2. So y minus y1 equals mx minus x1. So y is going to be equal to 2x minus 2 minus 1, which is 2x minus 3. So that's the equation of the graph, the tangent graph, and now we're going to put 5 in from the original equation. So 2 times 5 minus 3 is going to be 7. So A equals 7. There is another way of doing this if we know the gradient and we can find 2 points, we can find it straight away, but we'll stick to this method here for now. Moving along to E, so this looks like a bit of a tricky one. The function f of x is given as x cubed plus x squared plus bx plus 2 and has turning point where x equals negative 1 and x equals 3. Find a and b. Okay, so at a turning point, at the turning point, the gradient is f dash of x equals 0. The gradient is 0. So I'm going to, this pen is doing all sorts of funny things. I'm going to differentiate that, and hopefully we can find what a and b are by putting those in. I think we may need probably do a simultaneous equation to find a and b. But anyway, we know from the information there that f prime of negative 1 equals f prime of 3 equals 0. So that it equals 0 at the turning point. The gradient is 0 at the turning point. Okay. So f prime of x is going to be equal to 3x squared plus 2ax plus b. And we're going to set that equal to 0 at those points. Let's put the negative 1 in and see where we get. So 3 negative 1 squared, let's just show what we're doing, plus a negative 1 plus b, and that's going to be equal to 0. So negative 1 squared is positive 1. So 3 negative 2a plus b equals 0. And I'm going to bring this 3 over. So negative 2a plus b equals negative 3. That's 1 done, and now let's do it for 3. So f of 3 is going to be 3 squared plus 2a times 3 plus b, and that equals 0. So 3 squared is 9. 9 times 3 is 27. Plus 6a plus b equals 0. And I'm going to bring that 27 over. So 6a plus b equals negative 27. So now we have 2 equations and 2 unknowns. So let's do those in the simultaneous equation. So the first one is minus 2a plus b equals negative 3, and 6a plus b equals negative 27. So our candidate to get rid of first is the B bit. So I'm going to subtract this entire equation from the first one. So negative 2a, negative 6a is negative 8a. B minus b is 0 b's. Minus 3 minus 27 is the same as adding 27. So that's going to be 24. The b's go. So minus a equals 24. Divide both sides by negative 8. And a equals negative 3. So let's put that in here. So negative 2 times negative 3 plus b equals negative 2. So negative 2 times negative 3 is positive 6 plus b. So that b looks like a 6. It's a b. And that equals negative 2. So b must be equal to negative 8. So a is negative 3, b is negative 8. Because you could have just gone from here and plugged it into the calculator, but that wouldn't be as much fun. Oops, I made a mistake. This should be negative 3, shouldn't it? Because negative 3 is up here. So negative 3, so this should be negative 9. B equals negative 9. A equals negative 3. The next question is one of those questions where they want you to draw what f prime of x would look like on the same set of axes. So here is our original function f of x, and underneath here, I don't know why they make you do it underneath. They want you to draw what y equals f prime of x is going to equal. First thing we've got to do is find where the turning point is, and it looks like it's there at about negative a half. So negative a half is going to be what we've got there. It looks like a parabola, so we're going to say that the graph has the straight line that goes through at that point right there. Not at the origin. It has to be directly below the turning point. So the turning point there is about minus half, comma something. I'm actually head to B. We're about halfway through. The graph of the function f of x is 2x cubed plus bx squared minus 2. It has a turning point where x equals negative 1. Find the value of b. Okay, remember turning point? Turning point f prime of x equals 0. So if we take the original function, cubed plus bx squared minus 2, and we find the first derivative. So 3 times 2 is 6x squared plus 2bx, and the 2 disappears. And we put x equals negative 1 in there. It should equal 0. So 6 negative 1 squared plus 2b times negative 1. And that will equal 0. Okay, so we've got one equation and one unknown, so it's going to pop out for us. Negative 1 square is 1. 6 times 1 is 6. 2 times negative 1 is negative 2. And that equals 0. So I'm going to take 6 away from both sides. It should be pretty obvious what the answer is now. Divide both sides by negative 2, just to go through the mechanics. So b equals 3, because remember negative 6 divided by negative 2 is positive 3. All right, the next one, use calculus to show that the line y equals 15x minus 12 as a tangent. So there's that word tangent again. They were big on tangents this here, obviously. To the graph of the function f of x is this parabola here. All right, so what do we know about tangent? We know that the tangent is a place where they intersect, or they just touch each other at one place, and where they intersect, the gradient is the same. Oops. Let's speed up. The gradient is the same. So what's the gradient of this line here? When we differentiate that, we differentiate a straight line, we just get 15. A straight line has a gradient of 15. So we're saying that where these two lines cross, the gradient must be 15. Okay. First off, let's find out exactly where they cross. Where they cross, the first one minus the second one equals 0. Or this one minus this one is 0. Because the distance between them is 0. And applying this, we can also prove that it intersects once. So 4x squared minus x plus 4 minus this other thing here, minus 15x plus 12, because we're subtracting it, and we set that equal to 0 and then solve. So 4x squared, 0, and there is an obvious simplification here. Divide both sides by 4 minus 4x plus 4 equals 0. Okay, so now we want to know, is this a tangent? Does it touch it at one point? If that's true, then the determinant is 0. So b squared minus 4ac must equal 0. So minus 4 squared minus 4 times 1 times positive 4 must equal 0. So 16 minus 4 times 4 is 16. Yep, that does equal 0. So it must be a tangent there because it just touches it at one point where they cross. Okay, so now that we know that it's a tangent, we can use calculus. So there's one way of proving that it's a tangent, but let's use calculus. So we know where they're tangent, they have the same gradient. So in other words, when we differentiate this one and set that equal to 15, we can find where they cross. And hopefully it's the same places as where they crossed before. But let's grab our calculator and prove it. Okay, let's put both of these lines into our graphing calculator. So 15x minus 12. And the other one is 4x squared minus x plus 4. I'm going to draw them, and then we're going to, when I zoom and we see there clearly that one is a tangent, we're going to use G-solve. Where do they intersect? They intersect where x equals 2 and y equals 18. So 2, 18 is where they cross. So they cross at that point there, but let's use calculus to find it. So 4x squared minus x. So the original equation here is 4x squared minus x plus 4. I guess it's the same as one that's up here. That makes sense. And then if we differentiate that, we've got 2 times 4, 8x power 1 minus 1. And if we put in 2 into this, we should get 15. So 8 times 2 minus 1 is 16 minus 1 equals 15. Yep. The tangent, all right. Exclamation marks, extra marks. Oh, we're already up to D. Use calculus to find the value of k again. If the line y equals 6x plus k is a tangent, again tangent, to the graph of the function f of x equals x squared plus 2x minus 1. Okay. So the gradient here is 6. It's a straight line, so it's 6 everywhere. So we want to find where this parabola here has a gradient of positive 6. And we know that it's tangent because they tell us, so we don't need to prove that it is. So what we're going to need to do is we're going to need to find f prime of x and set that equal to 6 and then solve for x. So 2 comes out the front, the x, and we have a plus 2, and then we set that equal to 6 and solve for x. So 2x is going to be equal to 4. Take 2 away from both sides. So x is going to be equal to 2. That's where they cross. So we are going to put 2 in here and find what the y value would be. So f of 2 minus y1 again equals mx minus x1, if it sounds like a broken record. Y minus 7 equals 6x minus 2. So y is going to be equal to 6x minus 12 plus 7. So y is going to be equal to 6x minus 5. So therefore k equals minus 5. About that. Last one, E. E is probably the excellence question. So use calculus to prove that the graph of the function, this thing here, has a local maximum when x equals 9/4. And then justify that the turning point is a local maxima. So if a point is a local maxima, that would mean that f prime of x equals 0 and f double prime of x is going to be maxima going to be less than 0. That's right, it's the other way around. All right, so this thing is not really in the form that we want, so I'm going to just expand out that brackets. 3x cubed minus x to the power of 4. So y is 3x cubed minus x to the power of 4, and we want to find dy dx. It's in y form there, so let's do that one. So 3 times 3 is 9x squared minus 4x cubed. And let's find the second derivative. It's 18x minus 12x squared. Okay. So for this one here, we know that where the gradient is equal to 0, there's got 9 times 9/4 square minus 4 9/4 cubed. And we want to run a test. Does that equal 0? Let's grab our calculators. It's late at night, so, 9/4 cubed equals 0. Yes. Yes, it does equal 0. So therefore we know that it's a turning point. Is it a maxima or minima? Let's put in 9/4. So 18 9/4 minus 12 9/4 squared. And we really just want to see if this is greater than, equal to, or less than 0. So 18 9/4 minus 12 9/4 square, and that's a negative number. So it's a negative number. It's negative 81/4, so therefore it's a maxima. So it fits both of those conditions. Up to question 3 already. So the gradient graph of the function f of x is given by f prime of x. It's already differentiated, so it implies we're going to need to differentiate it. 6x squared minus 2x plus 4, and the 0.13 lines on the graph. This is what's called an initial condition. Find the equation of the function f of x. So what we're going to do is we're going to integrate that and put in the initial condition, because that helps us find c. Okay, so if f prime of x is 6x squared minus 2x plus 4, then f must be the anti-differentiation, I don't know what you call that, the integrand really. The 6 stays there, the x stays there, it grows by 1, and we have to divide by that because it's anti-differentiation. The 2 stays there, the x stays there, it grows by 1, we have to divide by that number, and the 4 becomes 4x, and we can't forget the c. So let's simplify that a little bit. So 2x cubed minus x squared plus 4x plus c is our original function up to c, but we need to find out what that c is. But we know that, oh, it's doing those weird things again. When we have 1 in there, we get 3 out. So 2, 1 cubed minus 1 squared plus 4 times 1 plus c, that equals 3. So 1 cubed is 1, 2 times 1 is 2, minus 1 squared is 1, and that's 1. Notice it's not negative 1 squared, it's negative 1 squared. Negative 1 plus 4 times 1 is 4, plus c equals 3. This is going to be, so 2 minus 1 is 1. 5 plus c equals 3. So therefore c must equal negative 2. So our original function is going to be 2x cubed minus x squared plus 4x minus 2. So the next one is another one of our graphing ones. They said now it's the other way around. So we're told that the diagram below, so this diagram here is f prime of x, and this is f of x if you're having trouble reading that. And they tell us that 0, 0 is on the curve. So when we differentiate, we integrate, we get like an extra hump. All right. So for here, between negative infinity and this point here, it's positively sloped. And at this point here, there's a turning point, then it's negatively sloped. And then there's a point of inflection, and then it comes up again, and then there's another turning point here, and this is all negatively sloped. So it's negatively sloped between here and here. And for here onwards, it's above the x-axis, so it's going to be positively sloped. And it goes through 0, 0. Okay. So from here, it's positively sloped. So it's going to look like that. And then directly below where it crosses, it's going to be a turning point there. And another turning point at, oh, it looks about half there and there. Okay. So it's going to go up and it's going to stop. And then it's going to go down through that point. And then directly below the other point, it's going to level off. And then it's going to go back again. So it's going to look like that. Maybe a bit out here, but it's going to have that general shape. We're at the kinematics question. So the rubber is really hitting the road here. An object can move in either direction on a straight track and has a constant acceleration of negative 4 meters per second. Okay, so the acceleration at any time is equal to negative 4, which means it's when it's going one way, it's slowing down, and then it goes the other way. Fixed point P is marked on the track. So I always do a little diagram. Marked on the track when the recording of the object begins. So in other words, when t equals 0, the distance is 12 centimeters from P. Okay, so let's say that's the displacement at time 0 is 12. And it's moving away from P in that direction and has a velocity of 6 centimeters per second. So this is obviously plus, it's moving away from. And it tells us that the initial velocity is positive 6. And the initial displacement is positive 12. Okay, using calculus, find the speed of the object. Again, they're sort of using velocity and speed interchangeably. And you can't do it in this case because the direction matters. after its motion began being recorded. Okay, the velocity as a function of time is the integral of acceleration as a function of time with respect to t, and the c is going to be v0, the initial velocity, and we know that it's going to be 6. So when we integrate minus 4 with respect to t, we get minus 4t plus constant, and we know that's going to be 6 in this case. So the velocity at any stage is negative 4t plus 6. And then they want to know the speed of the object 5 seconds after its motion began recording. So in other words, we want to evaluate this where t equals 5. So velocity at time 5 is going to be negative 4 times 5 plus 6. This is going to be negative 20. Plus 6 is going to be negative 14 meters per second. That's the velocity. So in other words, it's going in that direction. But the speed is just 14 meters per second. The velocity depends on the direction. The speed doesn't. It's just how fast something is moving. Bad question. Okay. Anyway, let's move on. All right. Next, they're asking, what is the maximum distance of the object from point P? And again, this is a really bad question, because if point P is there and we start there and we go out for a while and then come back again, the distance out here away from P is going to be infinity, isn't it? As t goes to infinity. I think they mean this bit here. Anyway, let's find out what this distance here is. So the displacement is t. We're going to need to find that and find where it crosses, where it stops. Where does it stop going outwards? It's when the velocity equals 0. Okay, so we can find out how far after when we started it has a velocity of 0. The logic is it's going here like this, and its velocity goes to 0, and then it comes back again. Okay, so we know from the previous example that v as a function of t is negative 4t plus 6. And we set that equal to 0 and solve. So negative 4t equals negative 6. So t is going to be equal to 6 over 4. So what, 3 over 2 seconds. Okay, so we know that after 3 over 2 seconds, it hits this local maxima and then comes back again. We're going to justify the distance in a second, but we need to find out what the displacement is. So displacement is s, because obviously d is taken in calculus. There's other reasons as well, but it's going to be the integral of velocity with respect to time, and the constant is going to be the initial condition. So it's going to be at 0, and we know from previous experience that is going to be 12. Okay, so when we integrate this, we get negative 4 stays there, the t stays there, it grows a 2. We have to divide by that 2. The plus 6 becomes plus 6t, and now we have the plus c, but we know that's 12. So let's 2t squared plus 6t plus 12, and we want to evaluate that where t equals 3 over 2. And we grab our calculator for that. It's just too late at night for me to be bothered with that. Negative 2, 3 over 2 square plus 6 times 3 over 2 plus 12. Whoop, that should be 3 over 2. Over 2 is better. 2t. That's right, yes. 33 over 2. So 15 point. 33 over 2 is 60. 33 over 2. So the distance, maximum distance is 33 over 2, which is 16.5. Yeah. 16.5 meters. But then you say, but this is a local max or minima. Okay, so how do we know if it's a max or a minima? We need the second derivative, f dash of x. If it's a minima, must be a maxima must be less than 0. But we know the second derivative of the position is acceleration. So the acceleration of t is given as -4. So therefore, it's a maxima. It's a local max. They gave us that in the beginning. And -4 is obviously less than 0. So therefore, it's a local maxima. Last question already. So find the maximum volume of an open box, i.e. a box with no base, with base and sides but no lid. Okay, that can be made from a rectangular piece of cardboard measuring 20 here by 30 here by removing corner squares and folding the dotted lines. So it's got to be a box. So this distance here must be the same as that distance there. So I'm going to call that x. That's x, then that's x, that must be x. That's x, that's x, that's x. As a function of x is going to be this distance here, which is 20 minus times 30 minus 2x times the height, and the height is going to be x. Okay, so let's get rid of these brackets. So 20 minus 2x and 30 minus 2x. So 20 times 30 is 600 minus 60x minus 40x plus 4x squared. So it's 4x squared minus 100x plus 600 all times x. So this is going to be 4x cubed minus 100x squared plus 600. And that's going to be the volume function. So a maxima, it tells us that the volume prime of x, not velocity, equals 0, and volume double prime of x, if it's a maxima, that must be less than 0. Okay, so let's differentiate this to find this and set it equal to 0. So 4x times 3 is going to be 12x squared minus 200. This is of x, not t, minus 200x plus 600. Just rewrite that. So 12x squared minus 200x plus 600. Yes, that works. And we're going to set that equal to 0. So 2x squared minus 200x plus 600. We're going to set that equal to 0 and solve it. And I just can't be bothered doing that for now. So let's use our calculator. Let's find the polynomial solver. Degree 2. So 2x squared minus 200, 600 equals 0. And we find that 96.904 and 3.0958. Okay. So 96.904 and 958. Okay, so if this is 20 across from here to here, this is obviously not going to be our maxima here. So X is not going to be there. So it's going to be here, 3.0958 business. Okay. Then we want to put that into the equation, and we want to differentiate that. We want to put that in and find the maximum value. Okay. So V58, we're going to get a value. I'm going to do that on the calculator, but I'm going to differentiate this again and find if when we put that in, it's going to be less than 0. It's going to be 4x minus 200. So 4 times some number, that's obviously going to be less than 0. So yeah, it's a local max. This 98.6 business is crazy. But for here, to find the volume, here we're just going to put it in our calculator, I think, and find the answer. Might as well. Didn't do it, then we still have the last ones from last time. Okay, so 4x to the power of 3 minus 100x squared plus 600x, and we're going to draw it, and then we're going to loom, and we're going to find this maximum point. So here's our maximum point, and if we go along, we're going to get this 96 business. So let's find what the maximum point is. G-solve, the maximum, and yep, 0.9. Something was missed. That's interesting. Two different answers. 4x cubed minus 100x squared plus 600x. Interesting. Maybe just as a learning point, put it in the original one there. So 20 minus 2, 30 minus x, and draw that. We should get the same drawing. G solve max. So 3.923. Okay, so 3.923. And the maximum there was 1056.305. And that's going to be centimeters cubed. So how did this get us this number here? Let's go into the calculator and solve. I'm keen to know this now. Polynomial solver, degree 2. 2, negative 200. 6, solve. It gives us a weird answer, right? I think this answer is wrong that it's given us here. There's an error, because I think this is the correct answer. I'm just going to use a better calculator. Okay, I just use a Texas calculator, and this one is the correct one. So it's maximized when x equals 3. What do you say it was before? 3.923 and change. So there's a bit of an error there in the Casio calculators. Fancy that. That's the end of the exam. Next up, who knows?